Hello everyone, welcome to the fourth day of this TezIndia blockchain bootcamp. Today we are going to start off with building the projects, and today everyone, I expect all of you to have your laptops and handsets ready with you to build. There's some few announcements before we start off. First announcement is that the certificates and cash prizes of the bootcamp would be provided to the winners only after submission of a valid project. By valid project, I mean that your project shouldn't be a copy paste from some other database. Like you shouldn't copy paste from some GitHub or any other thing like Stack Overflow. Okay. First thing, your project should be a valid project built by you only. Second thing, that always remember that your project should be based on the Tezos platform. You shouldn't build your project on any other blockchain such as Ethereum or Solana or anything else. It should be built on Tezos platform. This is one of the major points for your project to be a valid project. Second is that theme for your project or any suggestion, ideas for the project would be given by our own speaker today and tomorrow. Our own speaker, Ajasvi Rastogi, will help you in regarding that. Third is that for the submission of project, you would be provided a GitHub link. You can, if you have deployed your project, you can provide us the URL. If you have not deployed, you have built it in your own local environment system, you can give us the zip file. You can also give us the GitHub repository where you have saved that code online. You can give in any way, everything would be available in the Google form, so that you can give. Third thing, that while building, if you have any doubts regarding your code or regarding anything, you have any doubt, just ping me in the group. You would be provided one-to-one mentorship for the project from the Tezos India Foundation, and so that you can build your project easily. Now, I would like to turn the time over to Ajay Rastogi. Good luck, everyone, for today's session, and all the best to everyone. Happy coding. Or just say, I will just take the stage over and start building. I will just stop presenting my screen.
Hey, am I audible?
Yeah, just you are audible.
Okay, so I'll go and share my screen. Eh, hmm, all right. So today we are going to start with the development part. Uh, you will start developing smart contracts from today, and the blockchain that we'll be working on is Trezor's blockchain. So before making something on the blockchain, we always need to know about the blockchain. That okay, what are its properties and what's special in it, and how do we work with it. So before starting with the development, I'll just give a quick introduction to Tezos blockchain, and it will be good to open the website of it while explaining it. Yeah. So let's just open Tezos.com. So this blockchain is a smart contract based blockchain, which means uh, the functions that we had in Ethereum, which is developing your smart contract so that you can code your own algorithms on the blockchain, right? Uh, that that's that gives you more flexibility of how the people will interact with the blockchain. Because earlier you just have one application which is sending and receiving cryptocurrency like Bitcoin, but then Ethereum was introduced with smart contracts, and similarly we have Tezos blockchain, and it also supports smart contracts. So we can develop our own applications on top of it by coding smart contracts and then deploying it on the blockchain. Plus, there are also some problems with other smart contract based blockchains too, like Ethereum. That whenever we face any issue with the code of the blockchain, like for example consensus protocol, something like that. In that case, we need to, if we want to update the blockchain, then we can't do that because I mean blockchains are immutable, right? So in that case, we generally make a hard fork of that blockchain. Now, what is a hard fork? A hard fork is like a chain was continuously moving. We were like adding a block after the block after the block. We were making a chain of it, and then somewhere in the future, we observe that we need to change the blockchain from some block in the past. In that case, we can't do that because blockchains cannot mutate, right? So in that case, the community of the host, the community of the nodes, mutually decide that okay, we are going to make um, a new block which will be invalid according to the rules of the current blockchain, but we'll connect it with the some previous block and make a separate branch out of it. And this is entirely possible, but the problem is that some nodes agree to this concept and some don't. So the nodes which are agreeing will continue validating and making the minting the blocks with the new branch, and the nodes which are not agreeing to this change have they basically continue with the previous branch. So that's the problem. This way, two branches are created from a single blockchain, and that's called hard forking. And this is a very bad way of updating a blockchain because you are basically splitting into two pieces. So every value in that blockchain is now doubled, and that creates a lot of confusion. Like so, Tezos introduces a way of evolving the blockchain, which is in simple words, it's updating a blockchain using some mechanism so that there are no hard forks created. Um, so that's called a evolution process, and Tezos is capable of doing that. So Tezos was the first blockchain to use this concept. Plus, it's liquid proof of stake, which makes it very eco-friendly. It's one of the most eco-friendliest blockchain currently in the world. Like if I give you an example of the carbon footprint, the comparison of carbon footprint of Bitcoin, Ethereum, and Tezos, then this is what it looks like. Bitcoin consumes 130 terawatt hours. Then we got Ethereum, which only consumes 26 terawatt hours, but they are still too much. That is the energy consumption of them. And then there comes Tezos, which is 0.00006 terawatt hours, which is somewhat acceptable, right? So that makes it very eco-friendly and energy efficient because you can literally just delegate your coins to a baker and you can kind of stake just from your mobile phone. It's that easy. But in case of other blockchains, proof of work blockchains like Bitcoin or Ethereum, you need to host your own heavy duty machine like an ASIC or an array of GPUs to continuously mine the blockchain, right? So that is the way it works, and the code of this blockchain is so modular that it's very easy to update. It continuously keeps updating. We have already updated around 9 times, I think. So the blockchain have been evolved 9 times without a single problem. It have our own process of it, right? So just a second. Yeah. So yeah, that's Tezos. It was the official version of Manchester United for advertising now. Yeah, these are the protocols. So when I joined Tezos, I joined as a Tezos developer. The um, uh, Granada protocol was being added to the blockchain, but then Hangzhou was introduced, Ithaca was introduced, and now Jakarta is being proposed, and it will be introduced very soon. And with each evolution, new and new features into the blockchains are added. Like when I was coding smart contracts in Granada, there was no easy way of fetching data out of a smart contract. But then Hangzhou introduced views. So now you can make views in a smart contract and take take back the values that the view will be returned. So it's that easy. So when you come to the Tezos blockchain, it's very easy to develop smart contracts. For example, in many of the popular blockchains like Ethereum, you need to learn a language called Solidity, and you have to make smart contracts using Solidity. So you write the whole, you learn the whole syntax of Solidity and then make projects up onto it, on top of it. But on Tezos, it's kind of easier to develop smart contracts. Um, I'll also tell you about the the code which is used to run the smart contract. So basically, there's a code called Michelson, and whatever smart contract you write, it will be converted to Michelson, and then Michelson will be executed whenever you want to run the smart contract, right? And Michelson is kind of a low level language, and it's it's a stack based language. Like it's, if I give you an example of Michelson, um, I'll show how it looks like. These are all the syntaxes, but this is how it looks like. It's kind of very difficult to understand. Parameter, storage, pair, signature, string. I mean, it's kind of difficult to understand. And the more bigger the code gets, it's very difficult. So an easier way to develop smart contracts on Tether is by doing it some other way. So we got SmartPy. SmartPy is a way of writing smart contracts on Tezos blockchain in Python syntax. So if you know Python, it will be very easy to write smart contracts on Tezos. And Python is like the most easiest language to learn. It's known to, I mean, millions of developers already, right? So it's very easy to develop anything. I mean, I also knew Python from before, so it was very easy to just go and develop smart contracts on it. So yeah, we'll be using SmartPy. There are also other ways of developing like Lego. Lego is also one of the ways. And whenever you want to develop anything on Tezos, you can just go to developers and developer portal. So here it will give you all of the resources you need to learn Tezos. Everything from A to Z, everything. If you want to develop smart contracts, you got this. If you want to develop some front end and connect to the smart contracts, there are tons of libraries. The front end cannot be just a web app. You can develop an Android app. You can develop an iOS app. You can develop games on maybe Unity or Unreal Engine. You can also develop applications, have hybrid mobile applications using React Native. So TypeScript can be used for that, or JavaScript. You can develop Flutter applications. Flutter have its own library to connect with the blockchain. So there are any kind of .NET, that .NET also recorded. So these are the libraries. If you are developing with Golang, you can use TZGo. If you're using TypeScript, you can use Taquito. There are indexers and APIs which are very easy way to fetch any kind of information from the blockchain. You don't need to set up any kind of node or something. They already have their public nodes. Conceal is one of them. Conceal.js is kind of a small alternative of Taquito. Then we got Conceal Pi. And Morley is for Microsoft guys. Kotlin, if you are developing Android using Kotlin. Then we have PyTezos for Python. So there's another JavaScript library. So is also used in Taquito to build Taquito. Beacon is a wallet connector. So yesterday when we pressed the button connect wallet, we got a list of wallets that were supported to connect, right? So that's done using Beacon. Then we have TezBridge, another wallet connector, a Go library for Java and .NET. So all kinds of library whenever you want to connect any kind of user interface. And we also have many explorers. The best one, which I generally use, are TZKT and Better Colder. These are more than enough. And you have tons of resources to learn if you want to learn anything like there are even the courses. So this is our developer course, which will teach you about Smart Pi and everything. Crypto Wars is a very good way to learn in Smart Pi. I learned from here. Then P9 Labs also have a whole tutorial list of tutorials to get started with Tezos. Cryptonomics is also a very good uh, course to learn Tezos. And of course, you got Tezos developer documentation too. So, so the first thing we are going to do is make smart contracts using Smart Pi. So let's start with that. I'll search where is Smart Pi. Here it is, smartpi.io. Let's go to smartpi.io and let's have a look what's around there. Okay, so SmartPy is kind of a cool. It's not just a library or something. It's a complete IDE. You can literally code the smart contract into your browser, right? And you can code along with me when I will be coding the smart contract. So now we don't know how SmartPy works, right? So we need some kind of learning resource. Let's go to the documentation. Now, this is the page from where you will learn most of the smart contract development on Tezos. Everything you need and how to do this, how to do that. Most likely you won't find it anywhere on Stack Overflow, or sometimes you don't even find it in the Stack Exchange of Tezos. You might find some previous queries on the Telegram group of SmartPy, but still most of your doubts that how something is done using SmartPy will be given on this website, on this page, smartpy.io/talk. So I'll highly recommend you to just bookmark this because you will need it too much, right? So let's kind of go over the overview of it. So these things are, I mean, these things are to kind of tell you about the SmartPy CLI, which we won't be using for now. I mean, we can, but as a beginner, I will recommend you to just code on the IDE. So this is the simplest form of smart contract on SmartPy, and I'll explain it line by line. So the first thing is you just import SmartPy as FP. It's a very simple Python line. Whenever you want to import something, some kind of some package or a module in Python, you just write it like this. So we use the same thing, we just import SmartPy. And on ID, it's already there. So you don't need to pip install SmartPy or something. It's just right there automatically. And then a contract is like a class, right? I explained that in the previous session. So we'll generate a Python class only here. How do we create a class? We just write class name, and we inherit the sp.contract class to make our own class. So we have to inherit the sp.contract like this, adding it into the parenthesis, adding a colon, and then starting our own class. Now, whenever we are creating our smart contract, we always give a constructor so that we can we can specify what type of storages do we need. So the constructor of um, any class in Python is like this. We write dev, then we write init in double underscores, right, in the on the left side and the on the right side, and then we write self, which passes the current instance of the class, and then we can add any kind of value which you want. You can leave it empty also, and you can write any value also. And inside this constructor, we write this line self.init. Now this is the way we make a storage space in the contract. Okay, so we just write self.init. We call this function self.init, and inside the parameters, we write the name of the variable that we want in the class. So here the name of the variable is stored value. And initially, when this contract will be created, we pass a value, and that value will be stored in the contract, in the stored value variable of this contract. So this is what will happen when you deploy this contract. When you will be deploying this contract, you will add this contract onto the blockchain, plus you will also give a value in the constructor, and that constructor will be set as the storage parameter, storage variable, stored value, and that value will be stored as the value that you are given. So this is how you construct a contract, right? And then a class and also when you want multiple storage variables in a contract, you can do the same thing. You can just put a comma here and then write that name. Then again put a comma here and write that name. It's that simple. Now let's come to entry points. So if you are aware of Python, there are some things called decorators. I won't get into much details of decorators because it's a Python concept. But one thing you just need to know is that when you make a smart contract, uh, you want functions in the smart contracts which other people can call, and that will create the whole point of it, right? If there are no functions in the smart contract, then there's no point of that smart contract, because then no one will be able to interact with it. So you always need to have some functions in it, right? Now, how do we create those functions? This is how we create. The second line is very similar to any kind of function we create in Python. We just write def, the name of your function, add a step variable, and then some values if you need it. That's optional. It's up to you, whatever you are making. And always write the sp.entry point. If you don't write this sp.entry point, then you won't be able to call this function from outside of the smart contract. Yeah, in that case, it will be just called from inside of it. So for example, you write this function with entry point, and then you add another function without entry point. Then what you can do is you can call that second function inside this store function, and that will work fine because you are just calling it from inside of the contract. But you can't call that new function without entry point decorator from outside of the contract. So inside this function, we are doing a very simple thing. We are just writing self.data to access the mm, uh, state variable of this contract. So we got one state variable which is called stored value. So we just use self.data to access this stored value, and whatever value is passed in this function, we set that value in the stored value. It's that simple. This is a very small class which we made with just one constructor and a function and one uh, state variable. And this whole class will be used to deploy this my contract on the blockchain. Now in SmartPy, whenever you make a contract, you should always make some tests for it so that you can simulate the working of the smart contract. So I'll show you how that works. All you need to do is just in the same file you create a function called test and add a entry point called sp.add test, and then you can set a name also, and then you need to create a scenario which is like you're creating your own private um, blockchain into your browser, your own some private blockchain into your browser. So that will be a scenario, and then you will initialize this contract using this line. So I just initialize this my contract, give one value, this one, and then that will be stored in a variable called contract. Then I'll add that contract in the scenario. This is a very simple way to write that you are basically deploying this contract in the private blockchain scenario, and it will be just deployed on your blockchain. It won't be deployed in any kind of mainnet or testnet. It will just be deployed in your own browser, and then you can start calling the function. So we are simply calling contract.store and then passing the value to. So if you try to understand what's going to happen is that you'll just create um, this contract. Initially, the value of stored value will be 1, and then after we call this function, the value of stored value will be 2. That's it. I mean, it's so simple, right? And then you can also add some compilation target, which is the which is kind of a way of telling that whenever this contract will be deployed, then this is the value we need in the initial storages of the value, storages of the contract. So this is the line of it. We just call sp.add compilation target. We give it a string for printing in the console, and we call the instance of that contract that we want to deploy. So let's try to run this. I mean, we understood the whole code. Let's try to run it. So I'll copy this code and go to smartpy.io. And we got the ID here only. So, I mean, you might be seeing this screen. So I just toggle it to dark mode. And then you go to online editor. It takes time to load it. It's a, it's a very big file because you are completely like simulating whole blockchain process, and smart pi is also a very huge library, so it takes time to load. Give it some time. Okay. So when you open the ID for the first time, you will be welcomed using this dialog box, and it gives you everything you need to learn on your own. So you'll get a list of templates which you can always look at and learn, and you can write your own contracts here. Plus, there's a huge documentation. So I'll just close that and we'll start with the contract. So I'll name this contract like my contract here. That that was its name. So I'll rename it. Okay, and then paste that contract here. So and yeah, you cannot add comments in the same way you do it with Python. Okay. So when you write your kind of copy your first smart contract here, you can run that contract. So when you click on this button, it will do the process which is uh, told here. Okay. When you click on run, a new scenario will be created. The contract will be deployed in it, and it will be sorry, the contract will be initialized and then deployed in it, and then it will be called with a function. Let's click that. Yeah, and it also gives us the line number that whatever is shown here, uh, on what line is it there. Okay, so first we see line number 16 where it is deployed. So when it is deployed, this is the box of it, and when it's deployed, it's um, this is the code which is being deployed on the contract, and initially this contract is having a single state variable called stored value, and its value is 1. Just what we expected, right? Then as a second thing, which is a transaction. Now this was a contract deployment, and the second line, which is line number 17, is a transaction. And the summary of it is we are basically calling the store function, right? This thing tells us that the store function is called with a parameter value of 2, and also one more thing, that the balance of the contract was 0 test, right? I mean, it's just deployed, so um, the the balance of the contract is 0, and here also the balance is 0, and the storage, in the storage we already had one state variable, and its value is updated to 2 because that's what we just did in this function. So this is how the basic contracts are built on Tezos, and we can keep on looking in this um, documentation that what are all the things we can do. We can use the variables to do computations. We can write mathematical expressions just like Python. So what I can do is I just write plus equals to value. So this value will be added in the state variable instead of replacing it. So we pass 2 and the value is stored in 3, and we can create entry points, right? Entry points can have some more um, what do we call it, parameters in it. As a decorator, you can get some more parameters, and you can always look what is the meaning of it. We can specify its name, if it's private or not. By private, it means that it it's only available in test, right? So you can look at all the description, that what's the point of it. Dummy entry points, yeah, and yeah, sometimes um, sometimes you need some entry points which will return some value, and I'll explain that on kind of a whiteboard. Let me just open the whiteboard. So let's imagine we have a smart contract. There are some state variables in it and there are some functions in it, right? And we got another smart contract, which also have some state variables and some functions. Let's say just two functions. So sometimes what we need is we need the information of this smart contract, whatever is stored in this smart contract, and we want to fetch that data into this smart contract. For example, I am a user, okay, and I called this smart contract second function, and I want some of the information which is stored here in the state variables of this one. So in that case, we can create some functions in this smart contract, and this function will be called from this function. Now, now this function will be folded in the same transaction, and this function will fetch that data here and then return that into this function. And then we can keep on doing whatever we wanted in this function. So in that case, we are returning the data. So for that, we use sp.result. So it's kind of a return statement in Python. In Python, we write return and then the value, whatever we want to return from the function. In entry points, we use sp.result. Okay. And then we got some more kind of lazy entry points and stuff, which you can read. I mean, it's a whole documentation. You can read how whatever you want. Don't try to just uh, memorize everything like a book. I'm just showing you that whatever you need to do, you just come to this documentation and you can search it here. Like what do we, or let's say I don't know how to return some value. So I'll just return and it gives me some suggestion. Oh yeah, return value. I need to return values from entry point. Let's go and look at it. And from here you can start reading. So this is how you need to learn. Okay. And we all, and then it tells us about some things about smart contracts. So yeah, there is a one new thing which we see now, and that's called sp.verify. So this function is similar to require. Require is in Solidity. In SmartPy, it's called sp.verify. So whenever a function have sp.verify, once this function will start executing, it will come to this line, right? And it will see sp.verify. And in verify, you need to write some Boolean expression, any kind of expression which will return either true or false. And this is exactly what's written here. We write p is greater than self.data results. Now, if the value of p is greater than the value of x, in that case, the function will just check that here and then keep doing whatever is written in the further lines of this function. But if this expression is false, then the function will stop executing and the transaction will revert back and fail. In simple words, it will fail. So this is how you can kind of check the permissions or write some if statements that, like, for example, you are kind of making some authenticated system where you have written some functions uh, which only some authenticated people can call. In that case, you can use sp.verify to check the addresses of the caller, and if it's equal to the permitted people, authorized people, then you can continue the function. And else, if anyone else is trying to call that function who is not authenticated, then it will revert back and the transaction will fail. So sp.verify is a very handy statement. Um, and one more thing. So in storage and init is kind of same. It's just a small alias for in storage. So we won't look at that. One thing, yeah, I'll tell you is that update initial storage is a function which helps us to update the storage. So for example, here we initialize stored value, right? But somewhere in some other function, we want some more storage. We want some other um, state variable. Then we call update initial storage. And let's see if we have an example of it. So in this update initial storage, we'll update the initial state variables and then add some new state variables. So here x will also be added along with stored value. So these are all the storage things. And yeah, we can also specify the type. So that will be understood after we understand the types. Let's come to types. So typing. So there are data types. Okay, in any programming language, in Python also we have data types. I mean, it's a dynamic programming language, but we still have types. We got strings, decimals, floating numbers, characters, like Boolean. So in SmartPy also we have our own data types, which are used in the microsyn. So the first type is called NAT, and in the code it is specified as sp.tnat. So whatever type you are having, you will just add a capital T in front of it and then start the name of it with a capital letter. So tnat is a data type which is non-negative integers, right, from 0 to uh, further positive value. Then we got t int, very simple explanation, it's a signed integer value. Then we got int or nat. So this is the type which can be either int or a nat, and it's mostly used when you don't know what the value is going to be. Sometimes it can be just a nat, and sometimes it needs to be int too, and you are not sure at the time of coding that what it will be. So in that case, we use int or nat. Okay, and we got string also. There's a separate documentation of string. It is sp.t string, and whenever you want to, I mean that's not English, so yeah, that's just a what is it called, backward compatible thing, so it's not needed. We got booleans. It's called sp.t bool, just like this, and its value is either true or false. Then we got bytes, any kind of byte value, right? And then we have muters, sp.t meters. This value, this data type is used to store amount. Okay, so if you fetch the balance of some contract, then it will be returned as a t muters, and it's used to store the amount. And we also have uh, sp.tez to specify tez. And yeah, sp.muters is a constructor in which you pass some number and it will give us the value in the form of sp.t meters. So sp. In small meters, it basically means is that it's a constructor. By constructor, I mean it's a class, and you can enter some value and get the um, t muters instance, and then you can use it inside your smart contract. Similarly, we can use timestamps, address, okay, and then key, like public key or private key if you want to store it. The hash is like address only, signatures, chain ID. That's all the advanced stuff. If you will ever need, you can always read it. Mm, Yeah, one more thing. Um, Mostly you also need to store the values in the form of map. A map is like a mapping. If you're already aware of it, it's kind of easy to understand it. A map is a bunch of key value pairs. So you enter a key and you get a value out of it. So in case of array, you have an array, and in an array you give an index, which is some number from 0 to n, and when you give the index, you'll get the value of the uh, value of that index inside that array. Okay. Similarly, map also works in a some similar fashion. It's the only difference is you can specify the data type of index. Okay, so in array, indexes are always positive integers. In map, the index can be of any type. It can be a string, it can be a number, it can be a character, it can be an address, it can even be another map. Okay, and when you input that key, you can get out some value. So I'll show you the map, how it basically works. So you just write sp.map, and then whatever you want it to be, and then you pass key equals to the data type of keys, and then t value as the data type of the value. So here it's one and string, a number and a string. So tnat and string. Big map are very similar to map. They are just used when you don't want to iterate on a map and you want to kind of save some storage space. Then I'll also tell you about records. So records are like structures in C. If you know C language, there are structures. They are basically a set of multiple data types to create your own data type, right? So records are also same. You can just write it like sp.t record, and then the first variable, which will be the name that will be used to recall it, and then the data type of it, and then you can keep on adding using comma that whatever next type of variable you want in that record, and that will create a complete structure. A record, it's called a record in SmartPy. And yeah, there are all the types of uh, data types. And let me see if there's anything more, anything important. I'll just show control statements too. In Python, we got if. In SmartPy, we got sp.if, sp.else. That's just the um, old stuff that we don't need now. For, we got sp.for, so that it becomes sp.for x in params, very similar to Python. Similarly, sp.while, and then the condition, whatever condition you want to write, you can keep doing the stuff. This double basically means that you're dividing it by 2 and taking the floor value and then setting that value of y dot value in that variable. So it's that simple. You just, these are the things, the control statements, all of these are um, overwritten in SmartPy as a, so that we get the convenience of compiling it to Python. And we also have checking conditions like sp.verify. If you want something to check equal, you can use sp.verify underscore equal to and then pass the two values. However, you can always use sp.verify also and then write v1 equals to v2. It will just work just fine. Anything else? Views. Views are also, I mean, it's not needed to learn it today, but it's kind of the same thing which we were having in this example. So the function that we created here is basically a kind of a view. It takes whenever it's called, it takes the value of the state variable and then returns it. Views have the exactly same purpose. We create a view like this, off-chain view. Off-chain views can be called out from outside of the blockchain. And if you are talking about calling from inside of the blockchain, which we are doing here, you can create lambda functions or normal entry point. Right. Off-chain views can be called from outside of the blockchain, for example, from some front end that you are developing. Yeah, on-chain views are the things which we are using here. This is the on-chain view. And this is a very neat diagram of this. So we got a person who is calling some antipoid check token of contract A. Now, this contract, this check token will call the view token exists from contract B. Now, this is the view which will be called. It will be called throughout the transaction, that it will access the storage, and if it exists or not, and it will return the result. That result will be returned to the same line of the same entry point of the other contract, and that value will be returned here, and we can do the further computation. So it's like kind of a DFS framework. You go here, you call this thing is holded, then this will be completed, it will be returned back, and it will continue executing. These are all the same things. Yeah. Now let's try to make something, right? Let me just check if we are not missing anything. Yeah, one more thing, when we have maps are having many different keys and value pairs. But sometimes you just um, need to know that if a key is existing in a map or not. So for that you can use contains. So here, like if I give you this example, when this contract was initialized, it got tokens. And what is tokens? Tokens is a map. Like when we are instantiating, we are not instantiating here, but tokens is a map actually. Now this map will have some key value pairs, but in this function, we want to know that if tokens have a token ID or not. So we use this contains function. We call self.data.tokens to access this token map, and then we call dot contains. And in that function, we pass the token ID. So this will return a Boolean value that whether the token ID is existing in tokens map or not, in the keys of tokens map or not. If it exists, this verify will continue. This will be simply verified, and we continue in the next line. And if it doesn't, then this error statement will be placed. Okay, token does not exist. And if it exists, then we simply return it using sp.result and here we access that token ID value. So we call self.data.tokens, and just like array, we put the key token ID in that square brackets, get back the value, and that value will be returned as a result. It's that simple. So for now, this much is enough. We'll start by making something. Before that, if you guys have any doubts till now, if you think I missed something to tell about SmartPy or something in SmartPy, if you have previous experience with Solidity and you want to ask that how do we do that in SmartPy, you can also ask that also, so that things are cleared in SmartPy, and then we can move ahead. Yeah, programming is involved. Veeraj Desai is asking what tech stack is used for Tezos. Can we just use Python for development using SmartPy? And for front-end React, do we need to use Node.js? Yeah, Python is enough with SmartPy to develop your smart contract, and you can deploy it just from this ID only. And for front end, you can obviously go with React, and you can import the JavaScript and TypeScript libraries into your project. The library which I generally recommend to use is Taquito. Taquito have a very good documentation, very good maintenance. So you can import Taquito and um, read the documentation and uh, kind of connect it with the smart contracts. And we will also do that, I think, tomorrow. How user is authenticated for that? Is it through wallet or is it there any other way? Yeah, good question. I'll just tell you about that. So many times in a contract, you need to know who actually called that transaction, who is the one who is calling that function. So in that case, how do we know that? Let's try to search it. Um, who called entry point? Do we get something? Calls to entry point. Let's see if we can get something here. Sender, the simulated sender of transaction specific block. Yeah, we got it. So inside a function, you can use sp.sender to get the address of the who person or a contract who called that function. And then there's something called source, sp.source, which is the person who initiated that complete transaction. So I can tell you how both of them differ. For example, here, if we write sp.sender here, that will be the address of this contract because this function was being called from this contract. So that will be the value of sp.sender. But sp.source will be the address of this person's wallet because this is the one who initiated this transaction. So you can use these two things to authenticate, to basically check who is calling the function, who is actively trying to make this transaction. And then you can use sp.verify to check if it's equal to this address or not. If it is, then it's authenticated. If it isn't, then it will revert back. And sometimes you have uh, multiple people who you want to authenticate. So in that case, you can use sets. Let me search set. That's sets. Hmm. sp.set. Yeah, this should be enough. So sets are basically much similar to maps. The only difference is in this case we only got keys. There are no values. So set is like an kind of an array only, but its arrangement of the values in it are random. So you can initialize it like this. Okay, sp dot set, and then the array whatever you want, whatever values you want to store in it. And then you can use the set dot elements to get all the elements of it, which is a list. List is another name for array. And if you want to add something into into the set, you can use add function. So if we call there should be three, I think, because when you will call add and then three, then three will be added into this set and it will become 1 2 3. Similarly, you can call remove to remove an element, and you can always call contains to check if that value exists in the set or not. So if you want to authenticate a person and you have multiple addresses which you want to authenticate, so you can create a set of it, and if that address, which is sp.source, if sp.source is existing in that set, then it's authenticated, and if it doesn't exist, then it's not. So you can basically write it like this. Let's say there's a set named my set. Okay, so we can write it sp dot verify my set dot contains sp dot source, and yeah, we can write a error statement also that sender is not authenticated. It's that simple. But we don't need that here, so we just remove that line. That is how we authenticate. How many entry points can a class have? As many as you want. But also, the larger your smart contract, the larger fees you need to give while deploying it. Yeah, I want to start learning about blockchain and its development, but I just know basic of Python. Is it possible for me to learn it? And how should I start? I'm really confused. You should start with the first episode of this bootcamp, and it will definitely help you. No double data type. Double. No. Generally, you won't see decimal data types in any smart contract based language. And the reason for that is kind of a security issue, because when you have double things, the problem is, let's say you are dividing 10 by 3. So what will you get? 3.33333 or 3.33334? That's the confusion. So that creates security concerns, and sometimes it can even lead to exploitations and losing much of the money, right? So it's generally avoided to not have any kind of data type like that. If you want to do decimal calculations, you can always multiply it with some 10 to the power something to convert into integers, do a computation in integers, and then return the value. And mutase is built into this uh, Microsoft language. So we can use mutase along with tez to deal with um, decimal values of amount. Okay. So one more thing, there is something called sp.amount. Sp.amount can be used anywhere in the functions to know how much value the sender is sending in this transaction along with calling this function. For example, whenever this person is calling the entry point, it can also um send some cryptocurrency along with uh, the calling of this function. It's always possible. So that's a transaction, and whenever you need to check that how much money this person is sending, you can use sp dot amount to get that value. Plus, there is one more thing, sp dot balance, which is used to check the um, amount of the balance of the contract. So if you are using sp dot balance, it will return the value of the cryptocurrency which is stored in contract. In this case, that's zero. Also, how to print something to console? No print function. There is. You can just go here, print, anything like print. We kind of debug that, right? Debug, full debug mode. Okay, we can't go. I think we don't get any results here, but I know what it is. What it's called. It's let's go to here. Yeah, debugging contract. So there's a function called sp.trace, and then we write some expression, let's say some sp.data or something, and it will print that in the console of your web browser. Let's try that. Okay, so let's go to the id, and when we call this function, let's use sp.trace self.data.stored value. Yeah, let's go open the console and run this. We got 3. So this is how you can print whatever you want. I mean, a very basic hello world. Uh, your first project can be a basic hello world thing. So it will print hello world. Okay. And if you want to print something in the scenario, you can use sp.show. I think it's called sp.show, if I'm not wrong. It's not called show. Let me just uh, search what it is. There is a function which can just print it right there. Plugin, trace, solution. Is that sp.show? No. There's something else. I don't remember the name. But you will eventually find it in the documentation. I also find it there. Testing contrast, showing expressions. Yeah, there is. Okay, it's scenario.show, right? You can do that like this. Scenario dot show something's wrong. Yeah, scenario dot show and contract dot like any kind of expression. Yeah, contract dot data. Try it like that. Nope. Okay, we need to remove this. Right? Yeah. now it kind of print the whole state variables of this contract. And if you just want the value, you can write store value to print this value. It will just print 3. You can even okay, yeah, you can't do that here. Right. One more thing, sometimes you need to simulate people also in a scenario. So in that case, we have, I'll show you what it is. Let's say we can create a user, and that will be sp.test user, test account, so test account. And it's shown in the documentation. Initial user and test account. Yeah. So you can create any kind of user and then simulate the whole process in this test. So I'll pass some string here as a seed. Just pass user. It will create a new user for it. And whenever you're calling a contract, for example, we are doing it here. Here we can also give other parameters. For example, who is calling this function, or how much amount this user is giving in this function. So all of that is also specified in the doc. Bidding dynamic. Call 20 point. Yeah, dot run. You can specify dot run, and then you can write it as sender, right? You can write sender who is sending. You can set your custom source. You can set how much amount is being transferred. So let's say here the sender is user and amount is, let's say, 10. And within this function, we can sp dot trace, sp dot amount, and we can also sp dot trace, sp dot balance, not balance, but source. Most probably we will get some error, right? 10 is not a new disk. Okay, so the error it's showing is that in line number 20, which is here, I'm passing 10 as an amount, but the amount is money. So it cannot be the type of internet. 10 is a type of internet, right? But it should be mutex, and that is what it's telling us. 10 is not a mutex. So we need to give mutex. So I need to initialize sp.mutex here. Then write test. Play. And I should get something in the console. Just play it again so that it's cleaned up, right? The first amount is printed, which is mutex of 10, and then the source is printed, which is basically an address, and this is the address. That is the user. I can do all of that here. Now, any more questions? Yeah, no. So let's try to create something. Let's create a voting application. Okay. And it will be a very simple thing. It will basically have a question. That question will have some options, let's say true or false, yes or no, a Boolean question, and other people will be able to vote it, that what is the answer. And we'll also create a function to set the value of result, that which answer is correct. Okay, let's try to do that. So it's going to be a voting smart contract, let's call it voter or something. Poll booth. Let's call it poll booth. Now this poll booth will have a question. I can code along with me. Okay, and this question will be passed as a constructor as a string data. We'll initialize the value of question param. Let's say it's question param. We initialize it with question param, right? So that's one thing we always have in a poll booth. And what is, we also have two options of OPT1, let's say it's OPT1, which will be a string, and another option. One more thing, since we are initializing with multiple values, we cannot give like question param and then option param and then option param. A good way to do it is using records. So I'll just give params here, which we are expecting to be a record, and we'll type it here params dot question, so that this record will have a string called question, and then this param will have a string called option1, and it will also have a string called option2. Okay, these are things which we need in the storage. We also need the votes in both of these questions. Okay, so one thing we can do is we can have two nat type values to store the amount of votes for option 1, and then another value for storing the amount of votes on value 2, like vote 1 something equals, initially it will be 0, and then vote 2 equals 0. But what I think a better way to do is having a map, right? So let's have options, whatever that is, options equals sp dot map, yeah, sp dot map, and it's getting kind of tricky because we need the questions, and we need to add more, we need to add, okay, yeah, so let's do it that way. Initially the map will be empty. Okay, so initially the map will be empty. We can do it like this, or we can also specify the data type of it. So let's say let's do it with data type. We'll type t map, and then t key equals a string. It's going to be a string, p dot t string. We'll do it like this so that it looks kind of not messy. And we'll have t value equals sp dot t net. So this is how I'm planning it, right? We have a map called options, and it will be a map from strings to numbers. So the string will be the options, and the number will be the amount of votes. This is how I'm planning it. Now we need a function. Now when this contract will be will be initialized, it will have uh, it will just have a question, and then we need to call some other functions to add the options in it. Okay. Okay. Let's just do one thing. Copy this, paste over it, and then indent it properly. Yeah, like this. So now let's create an entry point. P dot entry point. Do we have something else? Just forgot if we have some params or not. Just a minute. No, we don't. Okay. Let's create a function. Add option, which will be having self and a param, which is going to be a string. And what we'll simply do is we'll insert that param in the option. So self dot data dot options dot add, and in the add we'll add a key value pair, right? So let's look at how maps work. We go to sp.map. This is map, and here what we need is access entry values. So adding. So how do we add it? Using this syntax. Let's do it. Options. In the key we want string, which is param, or simply replace that name with option string. And the value will be 0 initially because it's just added. No one have voted on it. And then we can add another entry point to vote. So let's set entry point. Def vote self, and then we need to add for which option are we voting. So we'll get option string, self dot data dot options option string plus equals 1. So we'll increment that value with the option. And that's it. That is a very small, simple voting dApp. Now let's create some tests to test it. fp dot again forgot that. Okay. That's why these dogs are so handy. You don't even need to remember anything. Add test, yeah, there it is. It's full boot. Def dot test. We add anything? No. Now here the first thing we need to do is initialize a scenario. Scenario equals fp dot what the scenario. Then and once we initialize that, we also need to initialize the contract. poll booth, and initially we need to give the string question, and we can pass any kind of string. Let's say we have a question like, is smart by easy? So that will create a new contract. Then we can deploy that contract in the scenario very easily. Scenario plus equals to contract. And then we can add options in it. So we can call, and yeah, one more thing, we can even write some kind of labeling. For that, we can use scenario dot h1. It's similar to h1 tag in HTML, right? H1 setting up, and then we can write label here that adding options, and then we'll call some functions to add the options. And also now we want to call the function and then add it to scenario, right? Well, let's do that. Contract dot add options, add options, and then in the parameters we want a string. So the first string will be yes, and then we want to add another option which will be no. Then we want to vote on it. Scenario dot h1 voting for the options, contract dot vote. We are calling the vote function, and in the vote function we need to specify for which option are we voting, which is the option string. So we'll just share the option string. Let's say yes, and let's do multiple voting. Some yes, some no. Okay, and let's try to simulate this one. All right, let's check what errors we are getting. The local variable scenario returns before sign. We are referencing scenario somewhere before even the sign. Turning up. Right. So scenario is being called, but it's not initialized yet. So we need to take it up there. Name poll booth is not defined. Poll booth is not defined. Okay. Is it not poll booth? Poll booth. I misspelled that. STR object has no attribute at questions. STR object has no attribute question. Yeah. So you remember that we were passing record here, not the question. But then we changed it to mapping. So now we don't record. Now we don't need record. We can simply remove params and then it will start working. But just for learning, we can keep it records only, and I'll show you how to use records for adding the parameters. When we are initializing it, here we need to add a record. So I'll type sp.record, and in the record, the parameter is question. So I'll type question equal the string. So I mean, we try to write it some kind of neatly. This is how we are doing it. We are just passing a new record in the constructor function. Now we got error, got an expected keyword argument TP. Hmm. This is something I was kind of thinking about, that this is not exactly how we need to do it. Let's see how we work with maths. Okay, so this is how we do it. We call sp.map. We give the value of L to set the initial values of the map, and then we uh, give the um, type of key and type of value. So we need L also. Let's do that. In the This will be a map, and here L will be equals to empty map. And there we go. We got H1. We initialize the contract. The contract have a storage of some key value mapping called options, and a question is marked by easy. Then we add the options to it. We call the add option. We cast the string yes. So that key value pair is generated here in the options map. Key is yes, value 0. Similarly, we add another um, another option as no. So now the key is no and the value of 0. And then we start voting. So as the first vote operation on line 40, we vote for yes. The value of yes is incremented using this line. Then we vote for something's wrong. Okay, we again vote for yes. We vote for yes two times. We do, we do. So yeah. So now it's 2. Then we vote for no. The value of no is increased. Then we vote for yes. The value of yes is increased. Then we vote for no. The value of no. So it works pretty okay, I think. You can add as much test as you want, as many scenarios you can think of, you can create here. And when you are confident enough, you can go and deploy it. So that's what I'm going to do now. I'll go above, and just where the deployment thing is shown in the scenario, you can find the deploy Microsoft contract option. Just click it, and you can look at all the initial storage of it. Like initially the storage is marked by easy. The Microsoft code, this is the Microsoft code of what we wrote. So this is how Microsoft looks like, and you can see the parameters of what's happening in the comments. Storage can be seen as JSON, and code can also be taken as JSON. But we don't need to worry about anything like that. All we need to do is click on deploy Microsoft contract. And for deploying, we need some test to give as a piece. Right. So let's check if we have something. Um, I'm not sure if that's enough. And I think I lost the account that was used yesterday. So I'll just quickly go and import a new faucet account. It will take some time to import. Yeah, it's imported now. Okay. One more thing, I just realized this is now code book. So let's click on deploy magazine contract. It will take me to a new origination page, which is specifically made for deploying something. Now we don't want to deploy it on mainnet. We want to deploy it on testnet on Ithacanet. We'll select Ithacanet and we got Temple wallet. So I'll just click on Temple and it will ask me to connect it. So I'll just simply connect that. Make sure you are connecting the account which is having some test. Okay. And then now this account is just imported, so I need to reveal that. I'll sign the transaction and it will reveal in some time. This is the address and the balance. Good evening. So entry point is overridable. Entry point is not overridable. The maps are like you can override the storage of the smart contract because yeah, we are overriding the storage. We are overriding self.data. That is the state variable of the contract. But the entry points cannot be overridden until and unless it's a type of entry point which you can override. Error boot object has no attribute add option. You might, I think you didn't create the add option entry point. This one. Maybe you didn't, maybe its spelling is wrong. Just check if the spelling is correct or not. So the account is revealed. Now, before making a transaction, we need to estimate how much fees do we need to give, how much should be the gas limit, and how much should be the storage limit. So I'll estimate that the numbers are updated automatically using the code. And then we can simply click on deploy contract. So it will show me the signature information that what is the hash that is going to be signed. You don't need to worry about any of this in case you want some initial value or something, then you might need to look at these things like the storage. The initial storage can be edited here, so that just can go these things. But for now, nothing of that is needed. You can simply click on accept, and then whatever it was asking for me to accept, it will just the wallet will show me the same thing in a bytecode format, which is completely unreadable to me, right? So I'll just click on sign, and then it will send that origination transaction onto the blockchain. And we are waiting for some block confirmations here. It's good to always show some block confirmation so that the user can easily get a feedback that how much blocks are confirmed and at what stage are the first is confirmed. I think let's try to go and look at this smart contract. Let's go to TezIndia in that Hacker enter this hash Yeah, this is the smart contract, which is just deployed 27 seconds ago, and it was created with balance 0. I originated this contract, and here you can look the um, the values of it. For example, this one don't have any tokens or what, but this one have some entry points. So I can look at the entry points. That there is a add option entry point which takes a string. There is a vote entry point which takes a string, and I can also look at the views. I don't have any views in this contract. I can look at its storage. So there's a question string which is marked by easy, and then we got map. Okay, we got map, which is initially 0. So now I need to make transactions on a smart contract which is actually deployed on the net, right? So for that, I need to make transaction on the smart contract. Generally, we make a complete front end for it, but as a developer, you have some tools to make the calls. And the best tool that I have is better called dev. It's similar to TZKT, but we can also interact on the smart contract. I will just go to this contract, and the same thing is shown here. 2 minutes ago, the origination was done. The storage was updated with with a with two things. One is question, which is a string, is marked by easy, and there are options which have 0 items. Now I can interact with this tab. So I'll go to interact and add some options. The first option I want to add is yes. We don't need to worry about optional settings for now. And then execute this. And I actually want to do this transaction. So I click on wallet. If I just want to simulate, I can use this also. But right now I actually want to do this so that it can be updated on the net. So I'll click on wallet. It will ask me to connect my wallet. And confirm. So I'm doing a complete transaction on the Ithaka net. The transaction is broadcasted successfully. Meanwhile, I'll also do a transaction for no. I'll just click no and then execute same transaction, same way. Click on confirm. That's also done. Let's kind of refresh this and let's see if we got the options or not. Okay, options are added. So in the storage now we can see 2 options, yes and no. Both are strings and the net values are 0. So now I can vote also. Let's click on vote. You can select the entry points from here, and then I want to vote on yes, and then execute. Confirm. Now we can play with this. We can also look at each of the transactions. Like the first transaction was adding a new option yes. The parameter was add option yes. There was another transaction which is adding a parameters no, and it was also added in the options map. And if I refresh this, I should also see a voting operation. It's taking some time to add it. Yeah, few seconds ago, the vote was also added. So I voted for yes. So the yes value was changed from 0. It was changed from 0 to 1. So now the storage is something like this. Yes is 1 and no is 0. Now I can copy this address of this smart contract and give it to you guys. You can also play with this. You just need to take this address and go to bettercall.dev, enter this address here to search it, go to this contract, go to interact, choose the voting option, or if you want to add some new option, you can use this. Enter the option, whatever you want, and then click execute and do the transaction. Just as a small exercise if you want. Okay, so that was today's session about coding smart contracts on the blockchain using SmartPy and then playing with it. If you guys have any question, you can ask it in the chat. Meanwhile, while you guys are figuring out things, I can probably create a new GitHub repository and add the code there. No questions? If you guys faced any problem, you can ask me. Or if there are no questions, maybe you can end the session.
If there are no questions, shall we proceed
Shall
to
we
the quiz
proceed to the
part?
quiz part?
Yeah.
Okay then.
Okay.
So
So
share the quiz
share the
link.
quiz link.
Ojasvi, you can
Or just
stop
you can
sharing
stop
your
sharing
screen
your
so
screen
that I
so
can
that
share.
I can share.
Yeah, I'm just figuring out that I'm not having the option to. Can you close my screen sharing? I think you can, right? Because I can't see if I have any option for that. Yeah, thanks.
I would request everyone to join the quiz so that we can start with the quiz. So we would start the quiz at 9:36. We will wait for a few more minutes and then we'll start. Let's see who aces today's leaderboard. We will end the quiz at 9:50 p.m. Only four players are remaining. Eight players are remaining to end the quiz. 22 of them have completed. So I guess we should wait a little more. We would end the quiz at no further delay. 10 p.m. would be the last. We would be closing the quiz at 10 p.m. So everyone who has not yet done, please be little fast. So it's 10 p.m. We would be ending the quiz now. Thank you all for participating. Let's see the leaderboard now. So kudos to uh, so kudos to Shashank for acing today's leaderboard with the points of 16,810, followed by Prakharoja with a small margin of 10 points, 16,800. And then comes Crypto Lucas with a total score of 16,600. Came in the top 10 today. There was a maximum participation in the quiz. That's all for today's session, guys. We will see you tomorrow in the last day of the boot camp. Hope you enjoyed today's session. That's all. Bye bye, everyone. Take care.